Hi, welcome back. In this lesson, we're going to be talking through configuring 802.1x on both wired and wireless devices and go over the components that make up that type of configuration. So let's get started. So what is 802.1x? So simply put, it's a standard for network-based authentication. Instead of just plugging a cable into the port and gaining access, the network device is going to be configured to offer up an authentication challenge to where the endpoint has to actually authenticate before network access is allowed. There are several components that make up this process. The supplicant is basically the endpoint. The supplicant is a piece of software that runs on the endpoint, whether it's natively integrated into the operating system such as Windows or Mac or Linux, or it can be a third-party add-on such as the AnyConnect Network Access Module or Funk's Free Radius. They have a supplicant as well too. The authenticator is the network access device. So this is the switch or the wireless LAN controller or the VPN concentrator that the end user will be connecting to authenticate against. The authentication server is basically the ICE server. And then we have any degree of identity sources, whether it's internal to the ICE or external, being Active Directory, LDAP, or some other provider. If we look at 802.1x in action, there's basically a couple different things to keep in mind. The endpoint is going to use what's called EAP, which is Extensible Authentication Protocol. All the communication from the network device to the ICE server is going to be over standards-based radius. So if we look at this flow, we're going to have an endpoint attempting to connect to the network. He's going to use his user ID, his password, his certificate, or whatever method he's configured for, and he's basically going to create an EAP request that gets sent over to the network device or the authenticator. The authenticator is going to take that EAP request and repackage it in a standards radius request. This radius request is going to go to the ICE server. The ICE server is then going to process it, do whatever he needs to do. For instance, if he needs to send it to an external identity source, such as Active Directory for lookup, he will do that. That will respond back of yes or no, in this case, yes. The ICE server will continue processing and send back an accept or reject. That gets bundled up in a radius request that gets sent back to the network device. Then the network device will flip that back to an EAP request and send that back to the endpoint. Now, if a port is unauthorized, it says authentication fails, but that doesn't necessarily mean you don't get access to the network. It really all depends on the configuration of the network access device and the configuration of your policies. Now, if we look at what happens if an endpoint doesn't have a supplicant, there's a lot of devices that don't, such as IoT devices, cameras, phones, printers. A lot of the devices now will support 802.1x based authentication. If they do, I recommend that you use those, but there are still many devices that do not. Like I said, IoT devices and primarily healthcare devices don't typically support 802.1x based authentication. Endpoints that typically don't have a supplicant, ICE can still authenticate them using what's called MAC authentication bypass. The switch will wait a specific period of time when it's configured for the authentication, and if it fails, it can fail over to MAB. The switch will then send the MAC address of the endpoint over to ICE in a radius request, and it should have to see if it should have access to the network or not. ICE can use MAB to dynamically profile the endpoint and instruct the switch to allow the endpoint on the network. ICE also has a number of methods to authorize users at endpoints on the network. ICE supports downloadable ACLs as well as the ability to leverage a named ACL. ICE can also assign a dynamic VLAN, and it can also assign a scalable group tag. So ICE is a standards-based radius server, but it also has some additional functionality that allow it to do things like profiling, BYOD, and posture. ICE uses RFC 5176, which is Radius Change of Authorization, or COA, as you will see in a lot of documentation. COA allows ICE to alter the authorization result after one has already been applied to the session. To use COA, ICE must have an active session in the session database. COA can be automatically or manually performed by an administrator. Some use cases are central web authentication, We come up, we have an authorized session, we pop a web portal page, we sign in, and then after we sign in, different access needs to be granted. That is done through a change of authorization. Another example may be if I come onto the network and I am profiled initially as a Windows device, but later on down the road, I have more specific information that says, hey, I'm a Windows 10 device and I want to do something different with that, I can use that as well too. It's also used in threat management and the adaptive network controller ANC policies that we talked about as well too. Now, if we look at the minimum required configuration for a switch or a wired device, I've got both switch configuration and I've got configuration that needs to be set on the ICE server. From a switch configuration perspective, the key components are the radius settings, the change of authorization configuration, the switch port configuration, which is either going to be based on what's called IBNS 2.0 or IBNS 1.0. IBNS stands for Identity-Based Networking Service, and we'll take a look at the differences between the two in the upcoming slides. From an ICE perspective, it's pretty straightforward, and we've already talked about these components in prior lessons. I need a policy set, I need an authentication policy, and I need an authorization policy. And those are the main components I need from an ICE perspective. The community site that we talked about earlier does have what's called a prescriptive deployment guide for wired access, and I recommend that you read that below for more information. If we look at wireless, from an ICE configuration perspective, we have the same configuration. I need a policy set, I need an authentication, I need an authorization policy. From a LAN controller perspective, I need a little bit less. I need radius settings and I need the change of authorization configuration for the wireless network. The ICE policy itself is very similar between wired and wireless. The only real difference is the type of request that's coming in from a radius perspective, whether it's an IEEE 802.11 request or whether it's an Ethernet request. So what happens if authentication fails? A lot of people assume that fail means fail and I get no access. Well, it really depends on how your policies are written. Wired configurations typically have both an 802.1x and a MAP configuration. So if one fails, the other one will take over and pick up. Wireless networks are binary, meaning I only have one type of authentication, and if I pass, I get on. If I don't, I don't. So there really is no concept from a wireless perspective of let me try 802.1x first, and then if that fails, fail over to MAP. There are typically separate configurations on the wireless network for each of those. Now, a key consideration on the wireless access controller or wireless controller is there's no dynamic VLANs. The access lists have to be defined specifically on the wireless LAN controller, and then we reference those in the ICE policy, but they are not dynamically assigned like they are on the wired side. And then wired networks, we can also do MAB or MAC bypass on the wired network as well too. We just have to have the network configured to do so. Now, we talked about the identity-based networking service, the IBNS 1.0 style versus the IBNS 2.0 style previously. If we look at an example configuration, the configuration for the 1.0 style is basically individual commands that are placed on a switch port itself. So we have the authentication configuration, we have the .1x configuration, we have the MAB configuration. We have orders and priorities. The key thing about this is the authentication is processed in a sequential order, meaning in this example, if I have, hey, I'm going to do .1x and then MAB, I'm going to do .1x first, I'm going to wait for that to time out, and then I'm going to do MAB. What this typically does and what this causes from a user experience perspective is that I have to wait. If I've got consistent configuration across the network devices, I have to wait for one to fail before the other one goes. So for things that are doing MAB, like IoT devices, maybe printers, maybe phones, there's a longer period of time before the device can be onboarded onto the network because he's got to wait for that first authentication to fail before he can trigger the next authentication. If I look at the difference between that and the IBNS 2.0 style configuration, it's quite a bit different. This takes the form of what we call an event class and action methodology. So the same policy construct that you're used to from a quality of service perspective is used for this as well. We look at an event, we define classes, and then we define actions for those events. This is called C3PL, or Cisco Common Classification Policy Language. Now, what are the differences between this and the IBNS 1.0 configuration? So we take a service template approach for the manager. So we have a service template that's defined that has all of our configuration, and we will look more specifically at these configurations in a little bit. Big difference is 802.1x and MAB can run simultaneously. So this allows for a better user experience. So user plugs in, he's configured for MAB, the port is configured for 802.1x and MAB. They can both run, and because I've done MAB first, he's going to win and he'll get on much quicker from that perspective. There is less configuration because most of the configuration is bundled up in that service policy called .1x default that you see down at the bottom. And there's also what's known as a critical MAB functionality. So now I have the option to say, hey, if MAB fails, then what do I need to do from that perspective, where before that option was not available. And just from the overall policy contracts perspective, there's better manageability of resources on the device. Typically, in a production environment, you're going to see the IBNS 1.0 style configuration on 3850s and below. With the new 9300s and the software-defined access configurations from Cisco, you're going to actually see more of the C3PL or the IBNS 2.0 configuration. If we look at a wireless configuration example, it's quite a bit different because most wireless LAN controllers are configured through the GUI. We basically have settings for radius, where we define the priority and the order of the servers, and then we have a checkbox that says, hey, we need to enable change of authorization or not, or an option that says we need to enable change of authorization or not. We also have this cool little thing in the wireless LAN controller 8.4 and above software that if we check it, it will apply all the default ICE configuration for us, making it even easier to configure this on the wireless side. Some more specific things, when we're setting up the WLAN, we basically go and we tell it what type of authentication we want. And we very simply say, hey, I want WPA, WPA2. I give it the radius servers that I want to use. And then I go in and I set it for ICE NAC. Very simple from that perspective, and this is very straightforward and really doesn't change from use case to use case. This is pretty consistent from customer to customer. Now we're going to look at a demo of everything that we just talked about, the configurations on the ICE side, the configurations on the device side. We're going to look at both a wired and wireless device, and we'll see some of the impact of those changes on the endpoints themselves.